Welcome to This Explainer. Look, if you are gearing up for your very first academic research project, you know you might be feeling just a little bit overwhelmed. And hey, that is completely normal. Today, we're demystifying the whole research process with some absolutely essential tips so you don't just survive your project, you're going to thrive. We're breaking down exactly what research is, why engineers and scientists actually do it, and how you can master the foundational skills you need to succeed.
To get us started, I want you to imagine a pretty high-stakes engineering scenario. Which battery technology is best for electric vehicles operating in cold climates? If you're the engineer designing this vehicle, guessing wrong means cars literally breaking down in the freezing cold, stranded drivers, and, well, massive financial losses for your company. You simply can't afford to guess.
Okay, let's dive into this. When you're faced with a massive problem like that, how do you actually find the answer? Do you just ask a buddy, do a quick Google search, maybe flip through a single textbook? The cold hard reality is that professionals have to rely on solid evidence, not casual opinions or quick web searches. Your engineering decisions need to be absolutely bulletproof. To help you build that bulletproof foundation, here is our blueprint for today. First, thinking like a researcher. Then, evidence over opinion. Third, the literature review blueprint. Fourth, synthesize, don't just summarize. And finally, selecting scholarly sources. Let's get right into it. Section 1. Thinking like a researcher. So, what exactly is research? Well, at its core, it's a systematic investigation undertaken to generate new knowledge or solve a problem using evidence. True research isn't random. It's a highly structured, deliberate approach to solving complex problems. You aren't just looking up an answer someone else already found, you're systematically using evidence to generate entirely new knowledge. To visualize this, think of it as a four-step cycle. You always start by asking a highly specific question. That leads you to systematically collecting evidence, then you rigorously analyze that information, and finally, you're drawing evidence-based conclusions. This cycle right here is the absolute heartbeat of all professional research. To ground this theory in reality, just think about some massive modern challenges. Things like improving solar dryer efficiency, designing safer electric vehicles, reducing communication delays, or developing IoT-based monitoring systems. Every single one of these relies on that exact systematic process. This is literally how the modern world gets built.
Section 2. Evidence over opinion.
So the crucial point is, if we need evidence, we absolutely need peer-reviewed papers. Why do engineers read research papers? To learn about new technologies, improve designs, and solve practical problems. But more importantly, reading papers ensures you aren't reinventing the wheel by repeating previous work. It gives your engineering decisions undeniable proof and support. Now you might be wondering, why can't I just use my textbook? Well, textbooks are fantastic for the basics for sure, but they move at a turtle's pace. It can literally take years for them to update. Research papers, on the other hand, report the absolute latest developments. When you need to know what happened last month in battery tech, your trusty textbook just won't cut it. Section 3. The Literature Review Blueprint. All right, so I want you to view the literature review not as some boring academic chore, but as a mandatory strategic step. It's a systematic examination and synthesis of published research related to a specific topic. Basically, you have to know what has already been built before you can add your own brick to the wall of knowledge. This blueprint serves some major purposes. It helps you understand existing knowledge, identify industry trends, and compare different approaches. But the biggest one? It helps you identify research gaps. It shows you the questions that haven't been answered yet, building a solid foundation for your new research. Honestly, no serious researcher ever skips this scoping step. Section 4. Synthesize, don't just summarize. Now, what's really interesting about this slide is that it highlights the single biggest beginner trap in academic writing. Look at the left side. A weak summary simply reports facts in a vacuum, like saying, Paper A designed an efficient solar dryer using forced air circulation. Okay, but look at the right side. True synthesis brings papers into a conversation. While Paper A focused on forced air circulation, Paper B investigated thermal energy storage. Both improved efficiency, neither evaluated high humidity. See the difference? That is synthesis. A successful literature review is miles away from a high school book report. It requires 4 dynamic actions. You must compare different studies, analyze their methods, synthesize the bigger picture, and critique their limitations. If you aren't doing those 4 things, you just aren't reviewing the literature. Section 5, Selecting Scholarly Sources.
Okay, so not all sources are created equal, right? You have journal articles, which give you original research, conference papers, giving you the absolute latest findings, review papers. These are absolute gold mines because they summarize many studies. Then you have book chapters for established knowledge and theses for detailed academic research. For your literature review foundation, you really want to rely heavily on that top tier: journals, conferences, and reviews.
And this brilliantly illustrates our key takeaways for today. Remember, research creates new knowledge. Engineers make evidence-based decisions, not guesses. Literature reviews organize and analyze research, and they are not just summaries. And finally, different publications serve entirely different purposes. Choose wisely based on the foundation you need.
To put this mindset into practice, you've got a few immediate action items in your virtual learning environment. First, download the provided journal article and textbook chapter. Second, complete the comparison worksheet to see those differences firsthand. Third, submit your 200-word reflection activity. And fourth, go ahead and tackle the 5-mark quiz to test your new skills.
Before we wrap up, I want to leave you with a provocative question to really think about. What makes a research paper fundamentally different from a textbook, and why should engineers rely on papers instead of only reading textbooks? Keep thinking deeply about that rapid pace of technology we discussed today. Keep thinking like a true researcher. Thanks so much for joining me in this explainer, and hey, good luck with your very first project.